This is Mr. Martin. This is a video solution for problem number 3 from Packet in Class on application problems for graphing sinusoidal functions. So for this problem, we're looking at number of hours of sunlight throughout the year. And important information here, the summer solstice, we've got 14.63 hours of sunlight, and then in the winter solstice we've got 9.72 hours of sunlight. And when you're working on these types of problems, it's also important to think logically about what's going on here. So we're talking about number of hours of sunlight throughout the year, and if we're thinking about a period, so the period for this is going to be the year, which would be 365 days. Okay, and we know that period is equal to 2 pi over b. Again, some more information here in part A. This is the function that we want to fill in the missing blanks, so we're going to need a, omega, phi, and b. And since we're working with 365 days as our period, and we know that 2 pi over b is our period, so that's going to equal 365. I can put that over 1. And in this case, actually, I'm going to replace this because this is my b value here, my omega. So I'm going to put in my omega. And then if I solve that for omega, I get that omega is equal to 2 pi over 365. Okay, so first important piece of information when we're trying to find the sinusoidal function, again, we've got to find a, we've got omega, we're going to have to find phi, and we're going to have to find b. Alright, so next, what I want to do here is give a little bit of information which you can look up or sometimes it would be given to you. We're going to need an XY point for this. So when we're looking at this summer solstice, we're going to estimate this to be day 172 out of 365. Okay, so I'm just going to give you that information, and if you were in class, I also gave you that information on the board. So this would be our x value. So day 172 out of 365 is a summer solstice, and there are 14.63 hours of sunlight. So basically what this gives us is an XY ordered pair of 172 and 14.63. Okay, so we've got this information as well. So let's just highlight some of this. So I've got omega, and I've got this XY ordered pair. Okay, now we've got our maximum of 14.63 hours of sunlight and our minimum of 9.72, so we can see that there's been a shift. If there was no vertical shift, then these two values would be symmetric about the x-axis. So one would be, say, 10 and the other would be negative 10, but in the context of our problem that doesn't really make sense because we can't have a negative number of hours of sunlight. So this whole thing has been shifted up, and from these two values we can find our vertical shift, and we can also find our amplitude. So let's start with amplitude. So I know if I find the difference between these two, that will give me the distance from the highest point to the lowest point. And then if I just divide that by 2, it will tell me what my amplitude is. So my amplitude is going to be 14.63 minus 9.72. That's the difference from the highest point to the lowest point. And then I'll just divide that by 2, which gives me my amplitude is 2.455, and that's going to be my value for A up here. There's my value of A. So now I've got this value. And next I want to figure out my vertical shift. Vertical shift. Alright, so if there was no vertical shift, then I would have 2.455 above the x-axis and 2.455 below the y-axis. So we can really use either of these 2 points up here to find it. I'm going to use the minimum point. So normally I would have a minimum at negative 2.455, but I've got some value of D, which I'm going to use the value they have here. We'll use capital B. And I know once I add in this vertical shift, I have to end up at where my winter solstice was, so that would be 9.72. Okay, now we could have done this with the summer solstice. We would have done positive 2.455 plus 14.63, and that would actually minus, we would subtract those two, but either way it doesn't matter. And if I solve this for B, I get 12.175. So that's my vertical shift. And if you make a little sketch of what's going on here, that might help you as well. So if you want to pause the video and make a little sketch of, you know, just a rough sketch of these 2 points and then connect it with sort of a sine curve. All right, so we've got B, we've got A, we've got a point for X and Y, and we've got our omega value. So I've got everything in this highlighted equation except for phi. So if I substitute in these values into my function, then I can solve for phi. So I am going to have my y value, which is 14.63, is equal to A. My A value was 2.455 times the sine of omega, which is 2 pi over 365, times x. The x value is 172, minus phi, and then plus our B value, so that's plus 12.175. Okay, and now what I need to do is I need to solve for this value in here, and it looks a little scary, but it's not really. I'm going to subtract 12.175 from both sides first. And I'm going to get 2.455 is equal to 2.455 sine of 2 pi over 365 times 172 minus phi. Then I'm going to divide both sides by 2.455. Okay, so on this side I'm going to get 1, and these are going to cancel out, which is why I divided by that in the first place. And I'm going to get that 1 is equal to the sine. I'm going to go ahead and simplify this as well. So the sine of 344 pi over 365, all I did was multiply 2 and 172, minus phi. So basically what I have here is I have the sine of some number in here is equal to 1. And I know that the sine is 1 at the top of my unit circle, and the angle there is pi over 2. So what that tells me is this whole thing here has to be pi over 2, because the sine of pi over 2 is equal to 1. So I know that pi over 2 is equal to 344 pi over 365 minus phi. And I'm going to go ahead, we'll do everything in decimals here, so I'm going to subtract this from both sides. And we're going to end up with phi is about 1.39. So if you want to go ahead and pause the video and verify that you can get that on your calculator, this is the last value that I need in my equation. So now that I have that, I know we've got y is equal to a, which we figured out was 2.455, times the sine of 2 pi over 365x minus 1.39, and our vertical shift was 12.175. And there's our sinusoidal function. Okay, and for part B, if you want to check, I'm not going to work it out here for you, but we wanted to figure out for part B, predict the number of hours of sunlight on April 1st, which is the 91st day. So we'll just substitute 91 in there, and you should get about 12.61 hours. And for part C, you can go ahead and draw a graph. If you want to check your graph on decimals, that's a great way to do it. And if you were able to get on the internet and look up the Old Farmer's Almanac to find the number of hours, I got 12.46, or 12 hours and 46 minutes of sunlight. Okay, so if you still have questions about this process, let me know. Feel free to rewind and replay, and we'll see you in the next video.